All right, back with practice final. We're doing question 4. Right now, we're just going to concentrate on part A here. And we want to find we would like to find big X of e to the j omega, which is equal to the Fourier transform of x sub n. So that's the goal. Now, let's write x sub n right here. We have 1 over 3 minus n u of minus n plus 2. Now, just like we did in one of the earlier videos, I think it was question 1 for the practice final, we need to make this exponent here, we need to make that look like this unit step. So we can do that by adding 2 and subtracting 2, because then that means we're not changing anything. So we have 1 over 3 minus n plus 2 minus 2 times this unit step. And we can rewrite that one more time. So we have 1 over 3 to the negative 2 times 1 over 3 to the minus n plus 2 times our unit step, negative n plus 2. And when we take care of that coefficient up front, we have 1/3 to the negative 2, so that's going to equal 9. And that's multiplied by 1 over 3 to the negative n. I'm going to factor out that negative sign, so that would be n minus 2 times u of negative n minus 2. All right, so, and we can take this a step further. Let's define something else. Let's define x sub 0 of n, and that's going to be equal to 9. Oh no, let's just leave it as, we'll have 1/3 raised to the n minus 2 times a delayed unit step, n minus 2. So then we can, from that, we can just write that x sub n is equal to 9 times x sub 0 evaluated at negative n. And we can take this one step further to make it look even easier. Let's define x sub 1 of n to be 1/3 to the n power times just a normal unit step. And then we can write that x sub 0 of n is equal to x sub 1 evaluated at n minus 2. So x sub 1 of n is our nice, easy looking function. So we, right from the table, it's table, what is it, table 5.1, it should be about 2/3 of the way down. And we can see that the Fourier transform, so big X sub 1 of n, big X sub 1 of e to the j omega is equal to the Fourier transform of x sub 1 of n. And using our table, that's going to be 1 over 1, is it minus plus, minus 1/3 e to the negative j omega. Now using table 5.1 and property 5.3.3, we have the time shifting property. So x sub 0, big X sub 0 of e to the j omega is going to be equal to, that's the Fourier transform of x sub 0 of n. And we can replace x sub 0 as x sub 1 shifted by 2. And using that table, we can see that that's going to be equal to e to the negative j omega 2 times x sub 1 of e to the j omega. And I'm sorry, I'm getting bunch of text messages here. Turn that off. So there is x sub. So now we got x sub 0, but now what we need to find is this x sub n, right? So let's write x sub 1 e to the j omega, and that's equal to e to the negative j2 omega times x sub, or this should be x sub 0 right there, times x sub 1 e to the j omega. Now, the Fourier transform of x of n is x, big X of e to the j omega, and that's equal to the Fourier transform of x of n, which is equal to the Fourier transform of 9 times x sub 0 evaluated at negative n. And we can pull that 9 right out front, and using table 5.1, and it would be time reversal, which is 5.3.6. That's going to give us that, what that table is saying to do is just evaluate this Fourier transform, but with a negative e to the j omega. So we would have x sub 0 of e to the negative j omega, which when you plug that stuff in, now this one doesn't count. This is kind of like a coefficient here, so we'll have 9 times e to the negative j2 omega x sub 1 of e to the negative j omega. And when we replace that, we'll have 9 times e to the negative j2 omega, and it's going to be 1 over 1 minus 1 over 3 e to the j omega. And let me just double check everything here, make sure it's right. Yeah, so that's correct. So I kind of went about this a long way by defining 2 additional functions, but this is to use these tables. I think this is a good way to do it if you're still unfamiliar with it, is start out with your easiest one and then just start going back. You know, define x sub n in terms of things that of functions that you know how to do, take an easy Fourier transform of it, and then just apply those properties from the tables. All right, I'll be back with parts B and part C in the next video. Thanks.